Well, welcome everybody. It looks like we're going to get started. We can wait a few more minutes for people to join, but I think we can go ahead and get going. This is the webinar from Chromatic 3D Materials titled Protective Polyurethanes, Creating Durable Masking Solutions. This webinar is being run by Jeff Tronis. He's an industry leader and he's the R&D operations manager here at Chromatic, and he's got a lot of interesting things to tell us about creating durable masking solutions. So go ahead, Jeff.
All right, if I can, there we go. All right, thanks everybody for joining. There'll be time at the end for questions, but if you've got some burning questions in the meantime, we can pause and talk about it at that time. That's fine. So, as Gailey said, I'm Jeff Tronis. I'm the R&D and operations leader here at Chromatic. I've been here about 3 years now. Prior to that, I was at Stratasys for almost 15 years. So I've been an additive for quite a long time, and before that, I did some other stuff too. But our team has got a lot of experience in the industry. Cora, our founder, is here, obviously, with bringing in her experience and starting up the company. And Bart in Germany. Bob is our VP of Sales. Brian is our VP of R&D with a PhD in chemistry. Garth's our lead additive engineer, and John's our VP of business dev. So we can point you in the right direction. If we don't have the answers, we can find someone who knows them. I was going to give you a quick introduction to our reactive additive manufacturing process, our Rexam process, prior to going into the masking solution. So we know kind of what we're talking about here. We've got a two-component urethane. We've got A side and a B side that are pumped into this static mixer that you're seeing in this video. The material is extruded and reacts at room temperature. You see the darker material that's being the newly extruded material, and the lighter, more lavender color curing as it's going, so it can build on itself. But there's a fast reaction that allows it to build on itself, a little bit slower reaction to allow it to bond to layers above and below it, so that we get really good performance. And so this is a balance of kind of the reactivity and the viscosities and all those things. So I will move on to the next slide. Talk a little bit about isotropic performance, right? So X and Y is what it is in the print directions. You get pretty decent properties typically in additive. And in this case, in the Z direction, we are seeing bonding across the layers. It is reacting across the layers. So the data here on our Chromo Resist 90 grade, you can see that it behaves very, very isotropically. And in fact, elongation and tensile are both slightly better in Z. I'll say that was a wash, but very good performance in the Z axis, right? And so we do print the box that you see there on the bottom picture, and we'll cut out a dog bone in that and pull in that direction as a normal tensile part. One of the other unique things about the reactive extrusion is it allows us to it prints dense parts, parts without voids. And I know this isn't a super exciting picture to look at because there's no voids or anything to look at, but a CT scan of a billet that shows no voids is a win for us. So looking at printing a fully dense part is a good sales pitch here. You can also print large parts. I've mentioned we don't print them in an oven. We can do that even without seeing slumping or warping. This large part, so the column in the middle needs to build on itself, obviously. And the data you see here is the thickness throughout the part, and showing that it's maintaining really good thicknesses between 3.1 millimeters and about 3.25 millimeters. kind of the whole way. And that's really all the nature of um, how fast it cures and whether it's slumping or not. So we were pretty pleased with being able to print large parts in ambient conditions, open environment, no ovens. We don't, it's very safe. We have um, recently done a health and safety report out of our Germany location, showing that the material is very safe and very safe to be around with no venting or those kinds of things. So that's a document we can certainly provide you with as well, if there's any need for that. Our process is also able to provide very smooth finishes on the parts, thin wall, smaller parts particularly. You can get the finishes you see here. There's no post processing on these, and you can get some very, very high resolution prints here. And we do have the ability. This material sticks very, very aggressively to most things. So fabric on the left-hand picture, the two left-hand pictures are printing on fabric. It allows us to make breathable spots, seal up locations, those kinds of things. And we can print on metal and plastics. In the third picture, you see a tractor pad. We replaced the worn out urethane pads on a old classic John Deere tractor, and it functions very well driving around in parades and things that he's doing. And also be able to incorporate sensors and other devices, lights and sensors and things within the print. And on the next slide, there's going to be a multi-material. I think on the next slide, there's a multi-material. And to me, this goes a little bit with the sensor as well. Like you could do a stiffer material, a sensor, and kind of a less stiff material. And you can use that as, to indicate whether or not you have contact or flexure, those kinds of things. It allows you to, like I said, embed the sensor, protect the sensor, but actually put it in the, right up immediately in the application. So the multi-material aspect here allows us to, generally we have a 2-component print, A side, B side. In this case, we have 2 A sides, 2 B sides, and on the fly, switch from one to the other. The bottom of this bellow that you see here started out as a Shore D65 part. And when we hit the transition zone, turned off the Shore D material, turned on the Shore A70 material, which is in green, extrude what's in the tip as the transition area, and then print the more flexible area in the middle, and then transition again back to a more durable, stiffer material on top. So it allows us to X, Y, and Z customize kind of where you want the touch and feel to be, and how you can place different materials in different areas, all within the same part. Our materials are very durable. That we have, in the case of an axle joint, qualified to 100,000 kilometers on a vehicle in a vehicle test. Roof components, one of the pieces on a prior slide where it was the printing on was printing a seal. That was a seal that had gone through 4,500 cycles on a convertible roof test, which outperformed the competing materials by far. And we have passed some tests with the National Institute of Aviation Research as far as flame resistance and its compatibility with in-cabin parts on an aircraft. So there's great opportunity for these materials, and we'll talk about this particular application a little bit more. All right, so I made a really simple mask. ChromaFlow 70, which is a Shore 70 material. It's kind of our workhorse. It's the middle of the road from a durometer standpoint. But it's very flexible. It's going to allow me to conform to substrate geometry, and that's what I wanted. I wanted something that was flexible to demonstrate that. Just an 8-inch OD, 4-inch ID, 1/10 of an inch thick. It was 3 layers. I could have easily gotten by with 2 and might have even been able to get by with 1. But like I said, the geometry was simple and the print only took like 30 minutes to produce, so I wasn't worried about it. And of course, I did black on black because that was just the way I rolled with it. I took the mask, sprayed fabric adhesive on it, and applied it to my workpiece. Turn off the sound here. Could have easily used different attachment methods here. Could have gotten fancy and embedded magnets in the print for sure. Could have included clips or all kinds of other attachment methods here, but I kept it super simple. And like I said, just applied it, and you'll see the bend in the metal substrate there. That's really just what I was going for here. And in this case, we'll see me applying aluminum oxide 70 grit abrasive media to strip the paint off here, off the part. And on the next slide, oh, did that slide again? Next slide, okay. We'll remove the mask, and it's in perfectly good workable condition still. So I applied adhesive to it. I can take this thing, I've taken it to the sink and use a little Dawn dish soap, a little soap and warm water, cleaned up that adhesive, and that thing is ready to go again. This was before and after. In fact, that was after. The after is after several uses. Um, I've used it several more times since, and it looks about the same. So it takes the sheen off a little bit. That's our natural as printed condition normally on the left. You'll see it kind of that gloss being taken off of it, but that material is standing up super well. Looking at a couple other opportunities here with different substrates with the same design. One of our chemical drums, an empty drum that we had laying around, and then a sheet of polycarbonate, right? Just to give us that different range of options here for us to go ahead and test out. And so from a big picture, right, things in this space to think about is we have materials that range from a Shore A55 to a D65. It gives us opportunities to, within the print, customize potentially where you want to be, right? Like if you do want to have kind of a hard angle in there and you want to design that in and you want it to feel solid and feel much more plasticky than urethane-y, you can use the D65. You can print in that shape, and then you can also have the edges be a 70 if you want, right? Because those might be the edges that are where you're going to be blasting up against, where you're going to be impinging up on. And you can certainly do that in multi-materials and in multi-colors. There are even, if I click back here a few slides, sorry, I want to get this picture. So the picture on the left even, so if you use something that was not black, right? So there's a little more translucent than black, and you printed it real thin, like on the left, that's one layer. You could even visually align it to features if you needed to, right? You could set up it so that it was thin, and you could set it up that way, and that would be a super durable print as well. And then back to where I was here. The materials machinables, particularly the Shore 70 and harder. So if you have fine features or you need a sharp edge where you're not getting it from a printing standpoint, you could post-process, you can machine that edge in. You could also potentially cast that edge if you wanted, so to speak. There's opportunities there. And if you have interesting applications that might need a little bit more engineering, we have resources here as well to help with those. But we have the flexible materials and the rigid materials. Again, in the multi-material, we're very solid. The material's dense. It's liquid tight, it's airtight. You could use it as you could apply it with suction if you wanted to a surface to hold a mask in place type of an application, or to pick up parts, obviously, but we're just talking about masking here. They're very durable, very reusable. Like I said, in this case where I use adhesive, just wash it off so that it's a little less tacky. I keep looking over here because I got the part sitting here in front of me that I've used many, many, many times. If it shows up in front of my face. All right. It's very protective. And like I said, there's many applications. You could use adhesive, magnets. You could make it multi-piece and snap it together later. You could have a living hinge. You could design in a living hinge. There's all kinds of options as far as what you could do from a design perspective here. And sort of other applications within the masking really are plugs. Easy to design a plug. They're very reusable. You lose a plug, you print another one. Pretty simple. Just overspraying and coating, as far as that's concerned, masking areas that aren't very kind of plug appropriate. Those as well, and potentially plating applications as well. So it gives us like a huge range of options here in the masking world as far as what we can do with these materials and these kind of designs. And here's our team. Like I said, we're available. We've got chemistry expertise. We've got printing expertise. We can provide you with solutions to masking and other things. So I feel like I ran through that real fast, but are there any questions?
I have a couple questions that came in, Jeff.
Okay.
And I think you did cover it. I know that you made a simple shape in the demo, but you can do more complex shapes, correct?
Yeah, absolutely. So if you, for instance, had a logo or text or something, right, obviously, that are much more complicated than the geometry that I put together, for sure. Yeah, those are very straightforward, very easy things to print up. No problems.
And you can do different colors also?
Yeah, I mean black, any color that you want as long as it's black, right? Kind of that's my 3D printing thing. But yeah, we certainly have other colors available. Um, we can customize, but red, um, blues, greens, black. I mean, yeah, we can for sure. Other colors are available.
And is there a specific 3D printer that was used in this, creating this masking
So
piece?
we've got a couple different 3D printers back in our shop, but it doesn't matter. It's not a masking specific printer. It's just a 3D printer. And in fact, we're more about the materials than we are about the printer. I'm pretty hardware agnostic from that perspective. We do sell a printer. If you need a printer, let us know. We can do that. If you have a printer or a gantry system or a cobot or something, right, that you want to have our tech integrated into, we can do that as well.
Does anybody else have any other questions?
Okay.
What I've got one, does Chromatic support customers who purchase a printer?
Yep, certainly. So we do have expertise in printing and designing parts for printing, design for designed for reactive extrusion printing for sure. Yeah, it's kind of we look at it almost as an engineer in a box service model sort of thing as we're selling a printer. We're around to support you. We want you to use the printer. We want you to be successful with the printer. And we will provide that support for sure.
We got a couple more questions in. Do you have any experience in biomade collaborations? Good question.
Biomed collaboration. So we are doing a little bit in bio as far as being as far as compatible materials and things. I assume that's what the question is around. So I would say send an inquiry if you've got something specific to talk about, if you've got a specific application, because we can get more into depth about it. I'm more just an engineer than I am the PhD in chemistry on some of these things. But yeah, for sure, if you've got more specific applications, I would say send in some detailed questions and we'll get some answers for you.
Okay. Anything else? All right, I don't see any other questions.
Well, I'd like to thank everybody then for their time and thanks for joining.
Okay. Thank you, everyone. This webinar will be available on the Chromatic website. Please feel free to reach out if you have any other questions. Thanks, Jeff.
Thank you.